So we're asked to solve this differential equation. And our first step is to identify what type of differential equation, because the different forms it take means we use a different template. First of all, we notice that it is non-homogeneous. So we're starting to think, okay, because it's non-homogeneous, we've got to do the homogeneous first and then the particular using that table of guesses. So that's our first step. The next step is to see that it's a second order, because we've got the second derivative going on. Now, with the template for second order, we've firstly solved the homogeneous. So first of all is to find YH, and so we've got, instead of writing d2y dx2, I'll just put y double dash minus 3y plus 2 equals 0. And the method we use for solving that, this is y dash here, the method we use for solving this is we let y equals e to the kx. Okay, so we've got y dash is equal to k e to the kx, and y double dash, second derivative, is k squared e to the kx. We then substitute back into that equation, and we get k squared e to the kx minus 3k e to the kx, and then for y we're going to put that, so that's plus 2 e to the kx is equal to 0. We know that e to the kx is unequal to 0, so we can divide by it, so we divide by e to the kx, it's not equal to 0. That leaves us with k squared minus 3k plus 2 equals 0. In previous work I've always used quadratic formula, but looking at this, it's going to factorise. I use the cross method for factorisation. What two factors multiply together give you k squared, well, k and k. These two have got to multiply together to give you 2. So we'll go 2 and 1. They're the only two factors that multiply together give you 2. And when I multiply along that arm, I get 2k. When I multiply along that arm, I get 1k. You always add them, but we've got to get minus 3k. So the only way we're going to get that is if both of these are negative. Because when you multiply negative 2 times negative 1, you also get positive 2. So that works. So this will be negative, negative. So my factors are k minus 2. K minus 1 equals 0. So we get k equals 2, or k equals 1. So that gives us our homogeneous solution now. So YH is equal to, and we go back to the general form when you get real roots, it's A, E, so we'll make this equal to K1. I'll make this one K2 and this one K1. So A, E, K1 to the X plus B, E to the 2X. So that's my homogeneous solution. The next step in the template is to have a look at the right hand side and come up with a guess for yp. So in the table, so we've got f of x equals e to the 5x. So our guess, the particular solution, and going back to the table, it's ce to the kx. So it will be ce, not to be confused with the k's up here, to the, got to maintain that value up there, ce to the 5x. Okay. We've now got to do the third step, And third step is to find y first derivative, y dash of p, and that'll be equal to 5c e to the 5x, and y double dash of p is 25c e to the 5x. And we substitute those back in the original equation. So we get, going back way up to this equation, substituting in for y double dash, and we get 25c e to the 5x minus 3 y dash times 5 c e to the 5x plus 2 c e 5x is equal to e to the 5x. What we can do now is e to the 5x is constant, so we can take it out at the front, e to the 5x outside of 25c, so e to the 5x, 25c, that'll be minus 15c, and then this will be just plus 2c, and that's equal to e to the 5x. 25c minus 15c is 10c, 10c plus 2c is 12c, so 12c e to the 5x is equal to e to the 5x. So the coefficient here must be equal to the coefficient there. So 12c must be equal to 1. So you got 12c equals 1. And that'll give us c is equal to 1 on 12. So my particular solution, yp, is equal to 1 on 12, because that's my c. This was my guess up here, c e to the 5x. So c is 1 on 12, e to the 5x. And then the fourth step of my template is to state the general solution, y equals the homogeneous solution plus the particular solution. The homogeneous solution was a e to the x plus b e to the 2x, so that's the homogeneous, plus the particular, so 1 on 12 e to the 5x. Now we go back and check to make sure that we've done everything and that there are no initial conditions, so we can't work out a and b down in our solution. We've gone through, done the homogeneous, we've had our guess at p, we've substituted in to find the value of c, and then we've stated our solution, and our solution is a e to the x plus b e to the 2x plus 1 on 12 e to the 5x.